Let's talk about formulas. First of all, what is a formula? Definition. A formula is an equation with a specific application. Okay. Meaning it's an equation that's used to find something in particular. For example, if you have a square, to find the area of a square, you need to know the length of its side. So here we'll say S for side. Okay. Then the area of your circle, of your square, is equal to the side length squared to the second power, like that. So here you have an equation. This is equal to this, and it has an application. It tells you here's how you find the area of a square. All right. Another example that's not geometric is the formula for converting between Celsius and Fahrenheit temperatures. If you have a Celsius temperature, then your degrees Fahrenheit is equal to 9/5 times your degrees Celsius plus 32. Okay. Now, the most common application for formula is to evaluate using a particular number to fulfill its role to find the value that is the purpose of that formula, to find what the application, to find the result needed for that application. So for example, these are examples of formulas. And examples of using formulas, we can go ahead and find the area of a square with side length of, let's say, 7 inches. Okay. Well, this formula tells you that the area is equal to the side length, which is 7 inches squared. So here, area is equal to 7 inches. That's going to get squared, which tells us that the area is equal to, 7 squared is 49. Here, we write this as inches squared to differentiate it from an inch. An inch is a linear distance. It's a distance from here to here. An area is two-dimensional. You cover not just a line, but some space. So the way we write that as inches squared, which is different from just regular inches. Right? This would be an inch. This would be a square inch. An inch, that is 1 square on each side. Another example, let's go ahead and use this one. If the temperature outside is 20 degrees Celsius, what is the temperature in Fahrenheit? So go ahead and give it a try. You're simply evaluating. Remember, evaluate just means take the number and plug it in. Go ahead and give that a try, and it also gives you a little practice on multiplying fractions there. Go ahead and pause the video, and once you have your degrees in Fahrenheit, go ahead and unpause and we'll confirm it. All right, so the formula tells you that the Fahrenheit temperature is equal to 9/5 times 20 degrees Celsius plus 32. Okay. Note that here this is multiplication, whereas this is addition, so the multiplication goes first. Right? The order of operations tells you multiplication goes first. Here 20 is like saying 20 over 1. So here that can be multiplied out nicely. Notice 9 is 3 times 3. 5 is already prime. And 20 is 2 times 2 times 5. 2 times 2 is 4 times 5 is 20. and then the 1 doesn't factor. And here, this reduces down. 5 divides 5 to give you 1. So now your denominator is just the number 1. 1 times 1 is 1. All right, 1 times 1. In your numerator, you have 1 times 2 times 2. That's 4. Times 3, which is 12, times another 3, which is 36. So 9 fifths times 20 would be 36. Plus your other 32 will give us 68. So if the temperature is 20 degrees Celsius, it's 68 degrees Fahrenheit. Now, the use of formulas is the way we usually see them outside of a math class, right? You have a formula that's given to you, and you plug in a number or a set of numbers to get a result. You'll see that done in chemistry, you'll see that done in physics, you'll see that done in economics and accounting. Right? Anything that involves numbers, you'll have a formula or a set of formulas. You'll have some numbers, and you'll be using those numbers to evaluate the formula. However, there is another use for, there's another way we can talk about formulas, and it gets us a greater amount of use out of them. Because right here, this formula tells you, okay, this is the formula to find area. What if I already had area? What if I already know what the area is, and I'm trying to find the side length? Over here, this formula tells you, all right, if you have the Celsius, you can plug it in, and that'll give you the Fahrenheit temperature. The one that's by itself, that's the one that you're finding, right? You're given the one that's inside of the operations, the one that's over here, and the one that's by itself, the one that's been isolated, that's the one that you're using the formula to find. All right, so here Fahrenheit's by itself, so we use that formula to find Fahrenheit. Here area is by itself, so we use that formula to find area. But what if I already knew Fahrenheit? What if I wanted to find Celsius instead? Well, then this formula doesn't help us. Now, we can depend on someone to give us another formula, but what we can do is we can rearrange formulas ourselves so that we can isolate a different variable. Meaning, okay, if the F is by itself, then this formula is used to find F. Now, if I could rewrite this so that C was by itself, then this same formula could be used to find C, to find the degrees Celsius. This becomes very useful whenever you're dealing with several related applications. Sometimes you don't want to remember 10 different formulas because, well, it's difficult to remember 10 different things. Instead, what you want to do is you want to be able to rearrange one formula. Even if they're written down, even if you say, well, okay, I'm not going to memorize all my formulas, I'm just going to write them down. It can still be difficult to distinguish which is the right one. Again, with my example, let's say I have 10 different equations that are related to each other. Which one do I use? If they're all related to each other, they all kind of look alike, meaning it's hard to distinguish which one I want to be using. So having lots and lots of formulas, whether it be because you're trying to memorize them or because you have them written down, is not ideal. Instead, what we want to do is we want to be able to rearrange formulas so that we can reuse the same idea to find different information than what was originally given. All right? So let's consider that same formula there, in fact. Let's start with this one. So I'm going to take the formula F. I'm going to stop writing the degree symbol. I'm just going to say F is equal to 9 fifths C plus 32. All right, so there's a formula that converts, and I've just rewritten that one. It's a formula that converts from Celsius to Fahrenheit. But let's say I wanted to go the other way around. Let's say I wanted the C by itself. So I could use that formula to solve for C. Well, that's the way we're actually going to state it. We're going to say solve for C. The language tells you which one you're trying to isolate. Solve for C means you'll be done whenever your equation looks like C equals other stuff. Okay, so how do we do that? Well, we do it the same way we solve any other equation. We isolate the variable. Here, notice that C would be by itself if it wasn't for this 9 fifths and for that plus 32. So we want to get rid of those. To get rid of these, what you want to do is you simply want to do the opposite operation of what's already there. Here, I'm going to start by getting rid of the addition subtraction. That's the first thing you want to get rid of. Makes everything much simpler compared to any other order. So let's subtract 32 from both sides. That way 32 minus 32 is 0, and now C is closer to being isolated. Notice here these are not like terms. That's a variable and that's not. So because they're not like terms, you can't actually combine them. So you just got to sit them next to each other. So you can write that as f minus 32 is equal to 9/5 c. So now the c is almost by itself, but you got to get rid of this 9/5. Okay, well 9/5 is being multiplied times c. So what I want to do is I want to divide by 9/5. Oh yeah, but keep in mind, dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So let me do it that way. Let me multiply this by the reciprocal. That way, 45 over 45 is the number 1, which is what I want. I want 1c by itself. But whatever I do on one side, I got to do on the other side. So it's going to be 5 over 9. It's going to get multiplied. Notice here, you multiplied everything here by 5/9, which means you got to do everything here by 5/9. So the way we're going to do that is we're going to indicate it with a parenthesis. Now, if you want to, you can then distribute. You can then say 5/9 times this and 5/9 times that. But most people just leave it like this with the parenthesis. So the formula for converting from Fahrenheit to Celsius is derived from this formula that we started with. And it is going to be 5 over 9 times f minus 32. Okay? So to go from Celsius to Fahrenheit, that's the formula we were given. F equals 9/5 C plus 32. And then to go from Fahrenheit to Celsius, you're going to plug in Fahrenheit to get Celsius. That one's going to be C is equal to 5 over 9 times F minus 32. Being able to solve for different variables in an equation allows you to make greater use of a single formula so that you can use that one formula to find multiple pieces of information. Let's see another example. This is one not from physics or chemistry or the STEM field where one is usually going to deal with formulas. This one is meant to illustrate the fact that formulas can be used anywhere. It's either used in lots of fields. This one comes from economics. Here, let's talk about interest. In particular, let's talk about compound interest. Now, here we're not going to go into much detail about how compound interest works. You would take a finance class or a math for business class for that. But here, I'm going to just pull one of the formulas that you see in an economics or a math for business class. This is for compound interest. The amount of money that you have is equal to your principal, the amount of money that you borrowed, or that you loaned, depending on your point of view, times the number 1, and that's not a variable, that's just the number 1, plus the interest rate divided by the number of compounding periods. Again, I'm not going to worry about explaining this too much. That's not really important to this right now. What's important is how to use a formula, not what the symbols of this formula are right now. Raised to the power of n times t. Okay? All right, so this is the amount that you pay back when you borrow money with compound interest. So you borrow that much money at a 5% interest, and it's compounded every month, so 12 times a year. T is the number of years that you borrow the money for. Okay. All right, so now here, let's go ahead and do two things with this example. One is we're going to go ahead and evaluate. Let's go ahead and find the amount that you paid back. How much do you pay back if you borrow $5,000 at 0.05, that's your interest rate, that's going to go where your R is, at 0.05, compounded monthly, so that means you're going to do it 12 times a year for 2 years. Okay. So here, this would be your P. That's called principal. That's how much money you borrowed. This is your R. That's your interest rate. Compounded monthly. That means that N that's the number of times per year you pay interest. Since you're doing it monthly, that's 12 times per year. And your 2 years, well, that's T. That's the amount of time that it takes you to pay everything back. Okay. Again, if you take an economics course, a math for business, an accounting course, things like that, you'll see this in a lot more detail. Here we just have a single example of something that's not from STEM, not from engineering or chemistry or physics. All right. So here we go. That's going to be A is equal to, and just plug in these numbers. It's going to be 5,000 times 1 plus R, that's 0.05, over. This N is the same as that N, so notice that's just going to be the number 12 for both this denominator and for this power right here. That's the number 12. And then that 12 is being multiplied by T, which in this case is 2 years. Looks like that. And there you go. Now we're not about to go through and do that manually because here that will take, notice that power, what's 12 times 2 is 24. I don't think I want to multiply this number times itself 24 times. So if you were taking a class in accounting and business or anything like that, you would then use either some software on a computer, you would use Excel, you'd use an accounting calculator or something like that to go through this. So here, it's enough to just say, okay, here I know how to set things up. So for a formula, you're taking some unknowns, you're evaluating them by substituting in specific known values and finding a result. Okay? So 5,000 is your principal, and it goes in there. Now, formulas will sometimes have constants. If they have constants, well, you just leave those there. You have your interest rate, you have the number of compounding periods. Sometimes the variable will appear multiple times in your formula. That's fine. You can just substitute in the number multiple times. And then T is the number of years. And there we go. Okay. Let's go ahead and have you try an example similar to this one, but we're going to make it a little bit simpler, literally. The example you just saw was compound interest. Let's give a formula for simple interest. So here, this is called the simple interest formula. There's more than one kind of interest. Right? The simple interest formula says that the amount that you pay back from a loan is equal to the principal, the amount that you borrowed, times the number 1 plus your rate times your time. Okay? So here I'm going to have you try 2 things with this. First of all, find the amount that you paid back. So here the formula is that A stands for the amount paid back. Find the amount paid back. If you borrow, let's say $2,000, with an interest rate of 0.05, with a simple interest rate of 0.05, to be paid back in, let's say, 4 years. Okay, so remember, that's your principal, that's your P, your interest rate, that's your R, and the amount of time it takes you to pay back, that's T. It's just the number 1. Okay. Here, there's no exponent in the simple interest formula. The compound interest formula does have an exponent, but this one does not. So here, this one you actually can go through. So go ahead and do the full computation. Go ahead and plug in the numbers and actually go through the full computation to get your final answer. This answer should be nice. So the other thing you're going to go ahead and try, well, actually, let's go ahead and just do this one, and then we'll do the next one. So go ahead and pause the video, give that a try, and then unpause when you have a result. All right, so let's take a look here. The amount that you pay back is your principal, that's $2,000, times 1 plus your rate, which is 0.05, times your time, which is 4 years. Okay, we're going to follow the order of operations. Parentheses go first. And within this parentheses, you have some addition and some multiplication. All right, so we're going to do the multiplication first. You take 0.05 times 4. Well, let's see, 4 times 5 is 20. And that's it. 4 times 0 is not going to do anything. Here our answer has a decimal 2 spaces from the end. This one doesn't have any decimals. So total, you move your decimal over 2 spaces from the end. So that's going to be 2,000 times 1 plus 0.20. Keep in mind 0.20 is the same as 0.2. So you can either write 0.2 or 0.20. Either one's fine. Now we do the addition, still in the parentheses. 1 plus 0.2, that's 1.2. And again, if you want to put the 0 there at the end, you can. Zeros at the end after a decimal don't change anything. So if you want to put the 0 there, you can. If not, you can just leave it. And finally, we do that multiplication. We're going to take 2,000 times 1.2. And that's going to be, let's see, that's 0, 0, 0. 2 times 2 is 4. 0, 0, 0. 1 times 2 is 2. And that's going to give us, it looks like 24,000, but don't forget your decimal. You got to take, this one doesn't have any decimals, but this one is 1 space from the end. So here your answer needs to have a decimal 1 space from the end. So that's $2,400. So if you borrow $2,000 with an interest rate of 0.05 to be paid back in 4 years, you end up having to pay back $2,400. Okay. Now let's try the other application here. Let's go ahead and take this formula, and you're going to solve for the interest rate. Okay. Go ahead and solve for R. Remember what that means. It means by the time you're done, your answer should have an R all by itself. So solve for R. Okay. So go ahead and give that a try. Go ahead and pause the video, and when you are done, when you've isolated your R, go ahead and unpause and we'll confirm that together. All right, so here we go. Our original formula says A is equal to P times 1 plus RT. Okay. Now what I want to do is I want to get this R by itself, which means we need to get rid of all this other stuff. All right? Now notice that this P is being multiplied times all of this stuff. Well, I don't want P to be multiplied times all this stuff. I want it to be gone because I want just this by itself. Okay, well, let me divide by P. Just like that. So those P's divide away, and we're left with the amount that you borrowed divided by your principal is equal to 1 plus rate times time. Okay, so that's better because now your R is closer to being by itself, but we're not done yet. Here, let's get rid of the addition subtraction. Subtract 1 from both sides. Okay. That makes this go away. 1 minus 1 is 0. That's all gone. Here, these are not like terms. This has variables, this doesn't. So you can't actually combine them. You just have to write it as A over P minus 1. But that's okay. All right. Finally, if we want the R by itself, we need to divide everything by T. Here the T's divide out, and you're left with R all by itself. Now here, this looks strange because you have a fraction within a fraction, but we can simplify that a little bit. If you have A over P, and you're dividing that by T, because that's what you're doing here, you're dividing by T. Remember that dividing by something is the same as multiplying by its reciprocal. So here that's the same as A over P times 1 over T. The reciprocal of T is 1 over T. So now, since that's multiplication of a fraction, you can just go right across. 1 times A is A, P times T is PT. So here A over P divided by T is equal to A over PT minus 1 over T. And there we go. There's our formula. So this is the same information as this, but it's from a different point of view. This formula tells you, if you know your principal, your rate, and your time, you can figure out the amount that you're going to pay back. What this one tells you is, if you know the amount that you paid back, the principal, and the amount of time, you can figure out what your interest rate is. So here, it's usually whenever you solve for a variable, it's written on the left. If you write it this way, that's perfectly acceptable. But just about every formula you ever see in any book is written this way, where you have this on the left. And that's the way you'll see it in just about any book that you ever read. However, if you write it this way, that is also correct. They mean the same thing. Notice that when you solve for a variable, you're essentially just isolating that variable. You're getting rid of the operations that are already there by using the addition, subtraction, multiplication, and division principles. The properties of equality state that as long as you do the same thing to both sides, everything is still going to remain equal, which means all of this information is also here. But by isolating this variable, you've now rewritten your equation to give a formula for a different quantity. Here, if you know the amount that you borrowed, the amount that you borrowed, if you know the amount that you're going to pay back, and you know how long you're going to hold the money for, that will give you the interest rate. All right, and there we go. That is it for our topic. If anybody has any questions, comments, or problems, please make a note of those and reach out. And I hope everyone has a nice day.